I'll start sharing my screen. Can you see my screen, sir?
Yes, sir. You can go to full mode, sir.
Yes. Okay. Hello, everyone. Welcome to this video. In this video, we are going to solve the previous year questions of ISRO 2018 from mechanical engineering for the subject engineering mechanics and theory of machine. In this paper, there were total 6 questions asked from these two subjects, mechanics and Tom. Let's solve them one by one. Coming towards the first, two blocks A and B of 1 kg each, and they are kept on a flat surface, one over the above other. The coefficient of the friction between each contacting pair is 0.2. If the lower block is pulled with a horizontal force F, the minimum value of F for which the slip occurs between the block is nearly. So in this case, we have two blocks of same weight, and we are applying a force F to block B. There is a friction in between block A and B. There is also a friction in between block B and the ground, and the coefficient of friction is given as 0.2 for all these surfaces, and we have to find the value of F for which the slip will occur in between the blocks. So this is from mechanics and from the equilibrium topic. So what we have to do is you have to draw the free body diagrams of both the blocks A and B, and use the equations of equilibrium in order to find the F. So I'll go to the next slide and we will start with drawing the free body diagram and using the equations of equilibrium. First, about the block number A. So we have a block A. Block A is 1 kg. So weight is acting downward, 1 kg. It's in terms of weight, you can write it as 9.81 Newton, and same amount of normal reaction will be there because block A is kept on block B. So there will be normal reaction from block B on this block A, and that is given by the same amount of weight what A is putting on the B. So let's call this as a N1 equal to 9.81. Now the another body B is subjected to the force F in the horizontal direction. We have 1 kg weight acting downward, which is 9.81 Newton. And and this block is kept on the surface. So surface will give one reaction, which is N2. And we should also consider that we are keeping the block A on top of it. So the force, the reaction because of it on A will be the weight of it, and you can consider it as N1. There is a friction in between the two blocks, which is, let's call it as F1, which is mu times N1. And we have F2, which is a frictional force in between the surface on the block B, which is mu times N2. F1 is a friction force in between the block E and B, and F2 is a frictional force in between block B and the ground. So if we look in the second figure, we can clearly say that the capital F is equal to F1 plus F2. It means mu times N1 plus N2. or yeah, we can simply write it as mu n1 plus mu n2. And this equation we can write by using summation of all horizontal forces equal to 0. So our aim is to find F1 and F2. In order to find F1, we should find the N1. N1 is already 0.81. So F1 is equal to 0.2 into 9.81, and F2 can be written as 0.2 into N2. So how to find the N2? We know that if I do summation of all vertical forces equal to 0, we will get that N1 is 9.81, N2 is also 9.81. So N2 has to be written as 9.81 plus 9.81, because we have weight acting downward, we have N1 acting downward, and the only reaction which is in the upward direction is the N2. So N2 can be written as 9.81 plus 9.81. And yeah, let's write it as 2.2 into 9.81. So we have N2. So if I put it here, 2 times 9.81. So we got F1 and F2. Now, if I put it in this equation number 1, F can be written as 0.2 into 9.81. This is F1 plus 0.2 into 9.81 into 2. So basically, it's a 0.2 into 9.81 into 1 plus 2 is 3. So it's a 0.6 into 9.81, which is 5.9 Newton. Okay, so the final answer in this case is 5.9 Newton. Hence, option A is correct in this case. Coming towards next question. This is from the vibration topic. If the natural frequency of the spring mass system on Earth is F, its natural frequency on the moon, where the acceleration due to gravity is 1/6 of that on the Earth, will be. We know that the natural frequency of a spring mass system can be given as under root of g by delta, where g is the acceleration due to gravity and delta is the deflection. So let's imagine this is on the frequency on the Earth, Fe, let's call it as. Now, the frequency on the moon, Fm, will be, we know that this has to be, now let's call it as G, E. E stands for Earth, and now it has to be for moon Gm by delta. However, G moon they have given as acceleration due to gravity is 1/6 of that on Earth. So 1/6 by of Ge. So I would write it as under root of Ge divided by 6 into delta. So 1 by root 6, if I take it out, I'll end up with Ge by delta, which is 1 by root 6 of Fe. So we can say that 1 upon root 6 times df, which is the natural frequency on the Earth. So option C is correct in this case. Coming towards next slide. Yeah, so this is we have a new question. This is from the flywheels topic. We have solid disk of uniform thickness is given, which is 20 mm. Radius r is given as 400 mm, and the mass is also given, which is 10 kgs. Is used as a flywheel. If it rotates at 300 RPM, so omega is given as 2 into pi into 300 divided by 60. Okay, so it's 10 pi, okay, in radian per second, and 300 is in RPM. The kinetic energy of the flywheel is what they're asking. We know that the kinetic energy of the flywheel is calculated by half of I omega square. Okay, we have already calculated the omega, that is 10 radian per second. We have to find the value of I. I is moment of inertia, and how it is calculated, that is mk square. If it is given as the circular disc type flywheel, then the radius of gyration is r by root 2, and the formula becomes mr square by 2. So I can be calculated as 10 into r square is 0.4 square divided by 2. So it will become 0.8. 0.8 kg meter square. Now, coming back to the previous slide, R is 400 mm. I have directly taken it as a 0.4 in terms of meter and calculated. So now kinetic energy is half of I omega square. So let me write it. Kinetic energy is equal to half of I is 0.8. Omega square is 10 pi bracket square. So 2 ones are, it will become 0.4. Okay. 0.8 divided by 2. If you do, it will become 0.4. So 0.4 into 100 into pi square. So it will be 40 pi square, which is 394.76. So approximately 395 joules is the answer. In this case, option A is correct. Coming towards next question. This is again from the vibrations topic. The length of the cantilever beam is reduced to 1/4. So imagine a cantilever beam which is of length L. The natural frequency of the mass m at the end of the cantilever beam of a negligible mass will be increased by a factor. So this is the cantilever beam. Initially we have with a length L. We know that frequency is given by under root of G by delta. And whenever you have a cantilever beam with a point load at the end, the deflection in this case is W L cube divided by 3EI, whatever is the weight W we are putting there. And yeah, so W is nothing but the mg, generated as mgl cube divided by 3EI. So the frequency can be written as under root of G divided by mgl cube divided by 3I. So Gg will get cancelled. Omega is equal to under root of 3EI divided by ml cube. Okay, this is the formula. However, what we are doing now is we are reducing the length to 1/4. So let me go to the next slide. Omega was under root of 3EI divided by ml cube. And at, let's say now L is changing 12/4. Omega 1 or new omega will be equal to under root of, let's call it as omega 1. Omega 2 will be 3EI divided by m into L/4 bracket square. So sorry, bracket cube. This 4 raised to the power cube will go in the numerator So 4 root 4 into under root of 3EI divided by MLS cube is what you'll get. And it is 4 root 4 times omega 1 is what we can say. Hence, the 4 root 4 means 8. So 8 omega 1 directly we can write, and hence option D is correct in this case. Coming towards the next question. This is again related to the work and power. A truck hauls a trailer at 60 kilometer per hour. So we have velocity, which is 60 kilometer per hour. When exerting a steady pull of 600 Newton, they have given us the force. That is how much force it is applying for pulling it. That is 600 Newton. If the work is done for 40 minutes, then power required is. We know power can be calculated as force into velocity. Force is 600 Newton into velocity is given by 60 kilometer per hour. So we have to convert it into the meters per second. So 60 into kilometer means 1000 meters divided by 3600 gives you in meters per second. And if you solve it, this 00 get cancels out with this. 6 ones are 6 6 and this 6 will get cancelled with this. So you'll have 10,000 watt, and it is 10 kilowatt. Hence option D is correct in this case. Coming towards next question. This is from the critical speed topic. So this is again from the vibration. A perfectly balanced rotor shaft is supported between the two bearings at both the ends. So we have the shaft. It is supported in between the two bearings, and deflection at the center is given as, let's say, 2 mm. The critical speed of the shaft in RPM will be, critical speed is like whenever the speed of rotation is equal to the natural frequency, or whenever the frequency of rotation is equal to the natural frequency of this shaft, we'll say that it will that will be corresponding speed will be the critical speed. Hence omega n in this case is under root g by delta, and this has to be equal to 2 pi n divided by 60. So from this we can calculate the value of n. G by delta, G is 9.81, delta is given as 2 mm, so it is 2 into 10 raised to the power minus 3 is equal to 2 pi n divided by 60. So ultimately, if we solve this, we'll get 70. So 9.81 divided by 2 into 10 raised to the power minus 3 is 70. Multiply by 60 divided by 2 pi gives you the n is equal to, which is approximately equal to 670 RPM. Hence option B is correct in this case. Okay, coming towards the next slide. Yeah, I think this is the last question from this year. So Yeah. So yeah, thank you all for watching this video. Everyone, welcome to this video. In this video, we are going to solve the previous year questions which were asked in ISRO 2017 Set 1 exam of mechanical engineering, and we'll be focusing on the questions which are asked in engineering mechanics and theory of machine subject. There were total 10 questions. Let's solve them one by one. Coming toward the first question, this is from the mechanics. The resultant of two forces acting at 60 degrees is 7 Newton, and when acting at a right angles is root 34. The forces are. So let's draw the figure for it. We have 60-degree angle. Then imagine this is F1 force, F2 force, and this is the resultant. We don't know F1 and F2 are same or different. In this case, this is the resultant. The value is 7. So F1 square plus F2 square plus 2 times F1 F2 cos of 60 is equal to 7 square. And second case they have given is when they are acting at a right angles, the resultant is root of 34. This is F1, this is F2, under root of 34. So F1 square plus F2 square is equal to 34 is what we can write. So we have an equation number 1, which is from the parallelogram, and we have the equation number 2, which is from the square. Okay, let's call it as a rectangle. Okay, because we don't know F1 and F2 are same or not. Yeah, options are not same, so it means they are different. So let's put the equation 2 into equation number 1. F1 square and F2 square, you can write it as 34. So 34 into 2F1 F2 cos of 60 degrees is 1 by 2. So this 2 will get cancelled out. Okay, this 2 is cancels out with the cos 60, and that is equal to 49. So F1 F2 is equal to 49 minus 34, which is 15. So look into the options and check which option gives you multiplication as 15. So the correct option in this case is option C. 3 multiplied by 5 is 15. You can also try to put this 3 and 5 into equation number 2 and check whether it satisfies or not. It should satisfy it. I hope things are clear. Let me go to the next slide. Next question is from the Tom, theory of machine, about the mechanisms and machines topic. It is asking us to, let's say, the cuts back criteria for determining the number of degrees of freedom of a mechanism, with L as the number of links, J as the number of pairs, lower pairs, and H as the number of higher pairs. We know the formula that degrees of freedom can be calculated as 3 times J minus 1 minus 2 times number of pairs with 1 degree of freedom. So that is, you can call it as a lower pair. So 2 times J minus number of pairs with a 2 degree of freedom. So higher pairs. So H, this is the formula. we have for the cutback criteria. So looking into the options, option C looks correct. We can clearly see um, these two are wrong because whenever we have a 2D mechanism, it has 3 degrees of freedom, right? Because it can translate in x direction, can have translation motion in x direction, we can have translation motion in y direction, and we can have rotation about z axis. So 3 times n minus j minus 1 comes from it, and only option A and option C has that part. However, minus 2j has to come because we have to subtract the degrees of subtract the constraints which we are putting here. So if we have a joint which has 1 degree of freedom, and yeah, so 2 times j you have to subtract from it, since we are considering the 2 degrees of freedom, or we are considering the motion in 2 directions. So that's why 2 multiplied by j has to be done. And however, in the option A, it is 2 into L, which is incorrect. So the correct option in this case is option C. Coming towards next question, which of the following type of gear train, the first and last gear is coaxial? This question is also was asked in GATE 2020. The correct option in this case is the reverted gear train. You know, the reverted gear train is the compound gear train. Let's say we have an input shaft attached to the gear A. Another gear B is mounted on a shaft to which gear C is also connected, and then we have a gear D, which is coaxial with a gear A. So this is an input shaft, or you can call it as a first gear mounted on this shaft is A, and the last gear is D. They are coaxial, and this gear train is reverted gear train. Coming towards the next question, the ratio of height of Porter governor to the height of Watt governor is. We know that in case of Watt governor, the speed is equal to 895 by h, n square is equal to 895 by h. However, in Porter governor, n square is equal to m plus capital M divided by small m into 895 by h. This is, you can say, Porter governor. So where the small m is the mass of the balls and the capital M is the mass of the sleeve. Comparing these two cases, we can say that if we take a ratio of it, we can clearly see that for the same speed, if we just focus on the h, it will be m plus capital M divided by small m. So looking into the option C looks correct. In this case, option C is correct. Okay, what they are asking is the ratio of height of Porter to the height of Watt. So it is, this is the, this part will come in the numerator. So that's why m plus m divided by m. Okay, so this is Watt, HW, HP. Coming towards the next question. This is from the mechanics. What they are asking in this case is we have a bar of 10-meter long supported supports a load of 6,000 Newton as shown in this figure. And there is a cable BC, which is horizontal, 5-meter long, and force in this cable and the bar is what we are supposed to calculate. So let's try to draw this figure. If you take the point C, at point C we have one force which is in the horizontal cable. Let's call it as F. This point is C, so let's call it as FCB. We have a bar which is AB. Let's call it as F. Sorry, this is AC bar. Let's call it as FCA. And we have a force which is acting downward, that is 6,000 Newton. This angle is 30 degrees, so this angle has to be 60 degree. And this has to be 30 degree because alternate angles are equal. So either we can use the sine rule or we can just do the summation of horizontal forces and vertical forces and get the answer. So looking into the sum of all vertical forces, the vertical component of FCA has to be equal to 6,000. So I would say FCA sine of 60 is equal to 6,000 Newton. Okay, or you can also write it as FCA cos 30 is equal to 6,000 Newton. And hence FCA is equal to 6,000 divided by sine 60, which is under root 3 by 2. Ultimately, you'll end up with a 6928 Newton. So we have two options here with a 6928. So either option B or D is correct. So in order to choose the correct one, let's find FCB. Horizontal component of FCA has to be equal to FCB. So FCB cos of 60 degree is equal to FBC. FCA cos of 60 degree, horizontal component of FCA is equal to FBC. So which is 6928 we just calculated into cos of 60 gives us FBC. Cos 60 degree is 1 by 2. So FBC is 3464 Newton. Hence the correct option in this case is option B. 3464 and 6928. Yeah, first is what they're asking. The force in the cable first. Cable is BC. So yes, BC is 3464, right? I think, yeah, correct option is option B. Then let's go to the next slide. We have one more question again from the friction. A body of mass 10 kg is initially stationary on a 45-degree inclined plane as shown in this figure. The coefficient of dynamic friction between the body and the plane is 0.3. The body slides down the plane and attains a velocity of 20 meters per second. The distance traveled in meter by the body along the plane is close to. So if you look into this body, the body is moving in the back downward direction because of the weight component of the weight is acting in downward direction, which is 10 kgs. So the component of weight in the downward direction is mg sine of theta. This theta is 45 degrees, so sine 45 I would say. As the body is in the motion, we cannot apply the equations of the equilibrium. However, by using D'Alembert's principle, if we apply the imaginary force ma, that is mass times the acceleration, so inertia force, which is equal and opposite to the sum of all the forces in the direction of motion, then we can assume the body is in dynamic equilibrium and we can apply the equation of equilibrium. Coefficient of friction is also given as 0.3. velocity is 20 meters per second. So, and they are asking us to find the distance. Distance can be calculated as h is equal to ut plus half of at square. We know that the body is initially stationary, means the initial velocity of the body is 0. So we can directly say that the distance is ut. Okay, this is one more formula is there. V square is equal to u square plus 2as. Since they have given that the body attains the velocity of 20 meters per second, the better approach for solving this question will be using the second equation, because we already know the v square, that is 20 square. Initial velocity is also known to us. We cannot use first equation because you don't have the value of let's say the component of the acceleration along that direction. So better to use the equation number 2. So 20 square is equal to 0 square plus 2 times acceleration into distance. Yeah, so in this case, if we calculate the acceleration, we will be able to solve it. So in the first case also, acceleration is needed. Apart from that, we also need the time. Whether they have given time? No, it is not given. So that is the reason we should follow the second equation. So the only unknown thing is acceleration in this case. Let's try to solve it. However, the final answer has to be like 20 square is equal to 2as. Let me go to the next slide. 400 is equal to 2 into a into s. This implies s will be equal to, so will become 200. 200 divided by acceleration. So now let's calculate the acceleration and put it into this to get the distance traveled. We know that by the summation of all the forces, mg sine theta is in the leftward direction, and that has to be equal to mass times acceleration in the rightward direction plus the frictional force. Frictional force is how much? The component of the force in the downward direction is mg, let's say cos of theta, and this is the normal reaction. So frictional force has to be mu into n. Normal reaction has to be mg's cos of theta. So I would say mu into mg cos of theta. Mass is same, you can cancel it out. So g sine theta is equal to acceleration plus mu times g cos of theta. So acceleration can be written as g times sine of theta minus mu times cos of theta. Theta is 45 in this case, so 9.81 into sine of 45 minus 0.3 into cos of 45. Sine 45 is equal to cos of 45, which is 1 by root 2. And if you solve it, the acceleration will end up with a 4.85. So 200 divided by 4.85 gives you the 41.23 meters as the answer. So the correct option is option C in this case. Coming toward the next question. This question is again from the trusses mechanics topic. What is the approximate reaction moment at the fixed support A for the loaded frame shown in the figure? Take the diameter of the pulley as 225 millimeter. So reaction moment. So if you focus the point A, what is the overall moment at point A? At point A, the moment will be created by this 200 Newton force and also the 500 kgs of mass which we are attaching. So from the 500 kg, the moment generated will be 500 into 9.81 into, this is the basically weight acting in downward direction, multiply by the multiply by the distance. Distance is 1 plus 1, that is 2 meters. On top of that, you have to add this radius of the pulley is 125 mm. Okay, so it has to be 2 meters plus 125 mm means 0.125. This is the moment because of the 500 kgs load, plus moment because of 200 Newton is 200 into 1. Okay, and if you solve it, it will be 10623.110 Newton meters. So correct option is option B in this case. Okay, this is creating a clockwise moment. This is also creating the clockwise moment. So we are adding them together. Coming towards the next question. This is again from the mechanics. A pin joint uniform rigid rod of weight 981 Newton and the length 1 meter is kept horizontally by an external force F as shown in this figure. The force F is removed suddenly. You remove this force F suddenly, what is going to happen? The magnitude of the vertical reaction developed at the support. So basically, the reaction will be developed at this support and we are supposed to calculate it. Okay. Let's try to solve this question. So whenever this support F is removed, what is happening? Body will try to rotate about this support, okay, because it's a hinge support, it will try to rotate. It will rotate at, let's say, the torque, or let's say torque, which is I alpha. It's rotating with I alpha. And in order to balance it, some reaction will be generated at the support. And so you can imagine like this 981 is acting at a, this is uniform rod. So 981 is like CG is somewhere here. So this is I alpha. And to balance that, we have a reaction at point at this support. Okay, it will create a clockwise moment. Sorry, it will create a counterclockwise moment in order to balance it. Now, I can write it from this. I alpha has to be equal to R into L by 2, okay, where R is the reaction. So in order to calculate the I alpha, what we can do is let's use how to calculate the alpha. Alpha is the angular acceleration or let me just make it more simple. R from this equation can be written as 2 times I alpha. Now, you know, I is ml square by 12 whenever you have bar which is hinged at one support. Okay, so then in that case, the moment of inertia is ml square by 12. Alpha in this case is we have to calculate 981 divided by so I can write, let's say, imagine, let's say this is turning Imagine we have force that is 981, which is acting at a distance 1/2, and this is in because of this we are moving body in a clockwise direction. In order to balance that, we cannot apply the equation of equilibrium here. However, by using D'Alembert's principle, if I assume a counterclockwise, let's say, inertial moment, that is I alpha, we can say that now the body is in dynamic equilibrium, and we can use the equations of equilibrium, and we can say this I alpha has to be equal to 981 multiplied by 1/2. So basically, I alpha is equal to 981 into 1/2. So alpha has to be equal to 981 into 981 divided by 2i. So it is 981 divided by 2 times ml square by 3. 981 divided by 2 into m is, let's keep it as it is. And yeah, 3 goes in the numerator. L is 1, so it is 1 cube. Now, if you put it here, it is in this equation 981 into 3 divided by 2m. This will get cancels out. L square means 1 square. So 2 into 981 into 3 divided by 12 into 2 ends up with 981. This 2 will get cancelled. 3 1s are 3 4s are divided by 4, we can say, which is 245.2 Newton. Hence, option B is correct in this case. Coming towards the next question. This question is again from the this is, I think, this is from the machine design rather. Okay, but let's solve it. The frictional torque transmitted in a conical pivot bearing, considering uniform pressure condition, or you know that we can design this basically the clutches, okay, where we can design it we can design the brakes on the basis of uniform wear or uniform pressure condition, and we can use that approach here. So if we have the uniform pressure condition, in case of uniform pressure condition, we know that the torque is given by 2 mu f into r naught cube divided by ri cube divided by 3 times r naught square minus ri square, and the basically the torque is given by 2/3. Torque is given by 2/3 times mu WR cosec alpha. This is the value, and the formula which I told was R effective, which is 2 mu f r naught cube minus ri cube divided by 3 times r naught square minus ri square. So basically, the option is D in this case. This is not from the mechanics or Tom. It is from the machine design. Okay, so I'll just star mark it. Let's go to the next slide. We have, I think this is the last question from this year. Let's try to understand. It's from the vibrations topic. We have mass of 2 kgs attached to 2 identical springs with the stiffness K is 40 kilonewton per meter as shown in this figure. Under frictionless condition, the natural frequency of the system is what we have to calculate. We know that these two springs are connected in parallel. So the equivalent stiffness is K plus K, which is 80 kilonewton per meter. And they are asking us to find the natural frequency in hertz. So let's calculate first omega. Omega is equal to root K by M, is 80 divided by 2. 80 kilonewton meter, so 80,000 you can say. So it will be under root of 40,000, is 200 radian per second. So the natural frequency n is omega divided by 2 pi. So it is 1 upon 2 pi into 200. So it is 100 divided by pi. It is 32, approximately equal to 32. Hence option A is correct in this case. So that's all from this year 2017. Thank you all for watching this video.